mesh method, super mesh. Consider the circuit. Okay, it has two meshes. If you define mesh currents, they will be I1 and I2. You can give any other names, okay? You can say IA, IB, IC, no problem. And because there are two meshes, you can write two equations. If you say V1, V2, and the voltage of this source, let's it be V source 1. Okay, let's write the two mesh equations. Start from the left bottom. There is a voltage increase. So I will say plus V1. What's V1? V1 is resistance times current. What's the current, mesh current entering from positive? Can you help me? What's the mesh current entering from the positive side of V1? Minus I1. Okay, I1 is the current of that resistor, but I need the current entering from the positive, so minus I1. Minus I1. Continue. There is a voltage drop of V source 1. I will say V source 1. I cannot write something like that, resistance times current, because it's not a resistor. Summation is 0. The second mesh equation, start from the left bottom. There is a voltage increase of V source 1. V source 1. Continue. There is a voltage drop of V2 minus V2. V2 is resistance times the current entering from positive, I2. Continue. There is a voltage drop because there is a switch from positive to negative. I will say minus V source 2 is equal to 0. Okay. Consider the set of equations. There are three unknowns. There are two equations. Okay, you need one more equation. It comes from here. What is the mesh current of this source? Okay, we know the current of the source. It's I source 1. It's given. You can write that current in terms of mesh currents. Okay, you will add the supporting currents. What's supporting I source 1? Which current is in the same direction? I2. Which current is opposing? I1. Okay. Sometimes there can be two supporting currents. You will say I1 plus I2. There can be two opposing currents, or one of them can be supporting, the other can be opposing. Okay. So I have three equations and three unknowns. Here, three equations, three unknowns. Okay, it can be solved, no problem. But some people say there is a super mesh here. Okay, you can solve this circuit, analyze that circuit using mesh analysis. It's not difficult. But some people say there is a super mesh here. Let me write the definition. Super mesh is a mesh including a current source. Okay, you can define a super mesh. It's a mesh, it's a loop actually, not mesh, let me say not mesh, it's a loop. You can draw a KVL equation, KVL loop. It's including only one current source. So you can say this is actually I1. You can say there is a super mesh like that. Okay, you have included the current source. You start from here, you continue like that. Okay, and you write the super mesh equation. So instead of two equations, on that circuit you will have only one equation. Write the super mesh equation. Super mesh equation. Start from here. Minus V1. There is a voltage increase. I will say plus V1. V1 is resistance times the current entering from positive. R1 minus I1. Continue. I continue like that, but not on the current source. I have included the current source. Plus V2 minus. There is a voltage drop of V2. Minus V2. What's V2? R2 times I2. Continue. There is a voltage drop again. V source 2. Continue. Okay, I have returned the same point. 0. Instead of writing two equations, it's enough. It's sufficient to write one equation in order to solve the system. And then write the super mesh equation. Write the current source value. I source 1 is equal to, in terms of mesh currents, supporting current is I2. Opposing current is I1. Okay. So in this system, there are two equations, two unknowns. It's easier than the previous one. Okay, it's easier to solve because the previous one, if you use the traditional mesh method, you will have three equations, three unknowns. But if you use super mesh, you will have two equations and two unknowns. It's easier than the previous one. It's a definition. Super mesh is a loop which contains a current source. That's it. It's a name, okay? What's your name? Alper. This is the name of that loop, super mesh. Okay. Okay, let's have a numeric example on this. Let me give some values. Okay, let's analyze that circuit. Okay, for example, the question is find the power generated on 10 volt source, okay, and use mesh or super mesh technique. Okay, so some voltages are already defined. Copy my circuit and try to solve. I need to define some mesh currents. Let me say IA, IB. Okay, and then I need to write the KVL equations. If I use the supermesh technique, sorry, if I use the first, let me do with mesh method. I will not solve, but I will write the equations. Equation 1 is, on the first mesh, start from the left bottom, minus plus, there is a voltage increase of V1. V1 is 5 resistance times the current entering from positive. The current entering from here, IA is entering from minus, so this current will be minus IA. Minus IA. And then continue. What's this voltage? Let me define some voltage. VI. Okay. So there is a voltage drop, VI. I have returned the same point. I will say summation is 0. Then the second equation, equation 2. Start from the left bottom. There is a voltage increase of VI plus VI. Continue. There is a voltage drop, V2. V2 is what? V2 is what? Voltage drop 10 ohm times the current entering from positive. It's IB. Continue. There is a 10 voltage drop. This side is plus, this side is minus. Minus 10 is equal to 0. Two mesh equations, but because there are three unknowns, IA, IB, and VI, there are three unknowns here. Okay, I need one more equation. It comes from the current source. 2 amperes is equal to supporting current minus opposing current. Which current is supporting, which current is in the same direction of 2 amp? IB minus opposing current, IA. Okay, I have written 3 equations and 3 unknowns. I can solve, but rather I can use the supermesh technique. Okay. In supermesh, I will write the KVL equation like that, including the current source. Let's write. That's equation 1. So I need 3 equations for mesh methods, but I will need 2 equations for supermesh. Mesh 1. Sorry, supermesh. Start from the left bottom. There is a voltage increase of V1, 5 times minus IA. Continue. Plus to minus, there is a voltage drop of V2, 10 IB. Continue. 10 volts voltage drop again. And I have returned the same point, 0. Then I will need the second equation. It will come from the current source. 2 amps is equal to supporting minus opposing. Okay, so it's very, very easier than the previous one. Okay, 3 equations, 3 unknowns. That set of equation is more difficult than this guy. So let me solve using the supermesh. IB is equal to, I'm rewriting the equation 2 plus IA, and insert IB in equation 1. Minus 5 IA minus 10 IB, IB is 2 plus IA, minus 10 is equal to 0. minus 5 IA minus 20 minus 10 IA minus 10 is equal to 0. So minus 15 IA is equal to 30. IA is equal to minus 2. IB is equal to 0. Interesting. Maybe. Okay. So I have solved the system for mesh currents, but question wants another value. What was it? Power generated by 10 ohm. Okay, what's the power generated by 10 ohm? Voltage times current, but this enters from positive or negative? Enters from the negative or positive of this voltage? Generated power means voltage times current enters from the negative side of that component. Voltage is already given, that's 10. What's the current entering from the negative? What's the current entering from negative? Minus IB. Okay? Minus IB. What's IB? 0. Minus IB, which is equal to 0 watts. Okay?